I think before we start the alignment, I'm just going to quickly check through some of these carbon resistors. These carbon resistors, you probably know, notoriously unreliable, prone to drifting. They've got the silver band on them, so they're spec to 20%, so anything plus or minus 20% is okay, and even, to be honest with you, up to 25% is probably okay for most resistors in a valve radio. It's not that critical, apart from some very few exceptions. So let's have a quick look through. We've got our DVM on ohms range on the left here, as you see. We're going to start on these couple of these resistors here. Now these look like 270k. So let's check this first one here. Oh bloody hell, that's near enough, isn't it? Okay, so that's 270k. I don't think they're going to all be like that. And of course some of them might be in circuit, so some of them will be reading lower probably than the values. That one's 300. That's more than I expect from a carbon resistor. Yep, that's okay. I think that's all right. I'm really reluctant to change these resistors if they're unless they're wildly out. There you go, 250k. Yep, that's fine. So I'm just basically going through these, making sure there's nothing that's horribly out of spec, like this one. What the hell is this one doing? Is that a bad connection? Okay, yeah, it's a bad connection, but it is pretty high, that one. That's 328k, so I think I might consider that one as a change. So that one's one to take note of. Got these ones here, 333, so 30 should be 33k. Orange, 333, and that's reading 470k. Bloody hell. That one's got to go. This one here, 330k. Don't believe that. Oh my. Okay. Well, these are going. That's supposed to be 330k. It's reading 525k. So that's mile out of spec. These are the two capacitors that I replaced with leaky capacitors. So I took some bad capacitors out and replaced them with some bad capacitors. These probably will be replaced, though they haven't got a huge amount of voltage on, so they may be okay, but I think whilst I'm at it I might as well just change them out for some better quality capacitors. That's the 4K7, that's a 5K2. We've got a 333 again here. These look crap, these things do. These seems to be these green things are rubbish. Wow, look at that. 660k. That's supposed to be 330k. That's doubled its value. That's amazing. I've never seen one as bad as that. So that's a 50% out. That's going. This one here. So that's a 22. So it's a 22k. 11. Was that a brown? Let's get the torch on it. Maybe. Yeah, it's red, isn't it? I don't know. Looks red to me. That looks like. Anyway, I think I'm going to change all those green capacitors. They look rubbish to me. Oh, there's another cap there I hadn't spotted. Okay, and let's have a look at this resistor here. That should be 227k. 33. Yeah, okay, not too bad. But these are going. Okay, we're going to shotgun these green resistors. They're rubbish. I've got a few more on the other side. Up here. Let's start up here. Torch, so you can see what. Let's start on this one here. So it's a 2K7. This should be. Unfortunately, you can't see both at the same time, can you? Okay, 2K7 reads 4K3, so that's no good. I don't know what difference this is actually going to make. I don't actually know where these are in the circuit because I haven't got the layout, but that's a 4K7. That's reading, as you see, 5K1. Another 4K7 here. Oh, bloody hell. It's actually reading almost intolerance. 4K8. This bottom resistor here. Another 4K7, and that's reading 5K5. So I think I've come to the conclusion that those green resistors are rubbish and they need to go. There is another little one up here. I'll show you. I'm going to just read that out the meter because I'm not going to get this all in frame. So this is an orange brown, so there should be a 330 ohm. and it's reading okay 293 ohms. That's okay. We've got a 100k here, that's reading 105. That's good. Got a 1 meg here, and that is reading, can find a connection to it, there we go, 1 meg, spot on 1 meg. That's almost a reference resistor, that one. And there's another 1 meg here. Oh, come on, stay on there. Okay, and 1 meg here, 780k. That's probably got something across it, so they're staying. That resistor. So it's basically all the green stuff. Anything green will remove and replace with something a bit better. Now I did spot that other capacitor here earlier on, and I'm not sure about this. Now I've come across these things before, so I might have to take this out and have a look. What I probably will do, all I'm going to probably do actually, because that capacitor's probably only got a low voltage across it, looks like a fairly low voltage capacitor. It's only got sort of like a couple of volts across it. I think we're going to just leave it in place. There's no problem with that. And actually, funny enough, when I changed all these capacitors, I didn't actually check to see what voltage it got. Most of these are cathode bypasses, and they've only got a couple of volts on them. The high voltage stuff is here on this left-hand side with the yellow caps here that I replaced. But as I say, most of this stuff is low tension. There's another capacitor down here that you might have spotted whilst I was going through. This Hunt's capacitor here. I don't care if that's leaky or not, because it's got a 220 ohm resistor in parallel with it, so I don't care, you know, as long as it's not short, we'll stay with that. So let's get these resistors out and get something in that's reasonably in spec. Right, I'm coming up to these resistors now. I've done the others on the other PCB, and it's a 4K7 resistor. I have no idea what wattage they are. They're pretty big, but they're probably half a watt. So the plan is to actually work out if I can replace them with some resistors that I've got that I know that are rated at half a watt resistors, which is like the equivalent to the TR4, and obviously they're tiny little things in comparison. So we need to work out what these resistors are dissipating. So I'm just going to go to sort of like a random resistor on the board, which is this one. I'm going to power the unit up with its external supply again, and when I'm feeding a 250 volts high tension into it, or B plus if you're a yank, so we're getting 28.72 volts across that resistor. So what we're going to do is we're going to work out the dissipation across that resistor. So I'm just going to do that calculation now. So we've got 28 volts. We divide that by 4,700, which is the value of the resistor, and that gives us 0.0, so it's 5 milliamps passing through that resistor. Just check that, yeah, 5 milliamps. So we times that by the 28 volts that we're putting across it, let's say 29 volts. It's dissipating less than quarter of watts. So you can see there on my phone, that's the dissipation across that resistor. So I'm going to I'm pretty happy that these resistors are going to be fine. I'm going to take these resistors out, the ones that are on here now. Let me just show you the size difference so you can see. There's the resistor with the crocodile clip in it. Let's turn the HT off so I don't stick my resistor across and get a wallop. I'm going to replace it with that resistor. Now in theory that should be okay. We shall see. And if it goes up in smoke, my calculations are wrong. Right, re-resisted it, for want of a better word. Okay, the resistors, I've replaced all the ones that were badly out of spec. This one seems to be okay actually. That one's okay. The rest of them have been replaced. Yeah, all replaced. All these are being replaced with new old stock carbon resistors. I don't know if they're carbon resistors or not that I've got actually, but there's stuff that we had kicking around at work that was used in the valve gear. And I checked the resistances before I put them in, and they certainly seem okay. I'm not sure if they're carbon or not, and they probably go the same way as these resistors have originally, but at least they're look reasonably original. This is the ones on this side here. They've all been replaced. Funny enough, when I first changed this resistor here, I wanted to measure the dissipation to see how much voltage drop we're getting across here. Because I put this smaller resistor in, powered the unit up, and I couldn't get anything out of the radio, and it was clearly drawing some current from the high tension, but nothing obvious. And I started checking around, thinking maybe one of the caps has gone short, or I don't know, something had gone wrong. And it's funny how, and it's always a good idea to do this, and I think everyone recommends it. If you're recapping or re-resisting a radio or doing anything really on it, it's good to every now and then stop, power it up, make sure it still works. Carry on, do a few more modifications, stop, power it up, make sure it still works. And sure enough, I'd done these resistors and I powered it up and it was clearly still working. I changed this resistor, went to measure the voltage drop across it, and no HT. So first thing you think, oh, you put the wrong value resistor in. No, right value resistor. Track it all through. This orange wire supplies the high tension from the incoming, and it feeds that resistor. Now it comes back to this point just where is it? Orange wire, just there. Had HT there, full high voltage there. Nothing on that lead there. And what it was simply was, this is solid core wire, and when I just poked that wire with a screwdriver, it just snapped. So I had to remake that. So that's why it's always a good idea to just keep an eye on these old radios and sort of wiring like this, because it will save you a lot of time. I mean, they're fairly straightforward. You just have to track the voltage down and find where it's missing, but if you can do it in stages, it's a lot easier. So that's it, re-resisted. I think basically that is all it's going to need, really. As I say, there's a couple of other resistors up here. You can see these sort of like resistors up here. This is a carbon resistor. They're all within spec, really. Let me just give you a bit of light. There you can see it's that resistor there. Most of it is okay, apart from the ones I've replaced. Usually the ones that go out of spec are the ones that have got the load on them, the high voltage across them. They tend to sort of go out of spec and slightly go high. So I say it's debatable how important that is. Probably not that important, to be honest with you, on a radio like this. But it'd be nice to get it into sort of like closer to its specifications of when it was new. So you can see the resistors I put in there. Try to make it as tidy as I can. It's always a bit tricky reworking on these tag strips, because you can never always get the sort of like the wire that was in there originally from the original resistor as a pig to get out of the eyelet that's in there. So what you tend to end up doing is just wrap the resistor leg around the tag and wrap it around the other end, and you see that's a pretty secure job. And this is a couple of the other resistors I've done. There, those two capacitors I think I'm going to have to change. I need to check the voltage across them. Shame really, because they fit in nicely, they're nice and tidy, but because they're paper, they've got to go. There's no point in replacing paper capacitors with paper capacitors. It's slightly different with the carbon resistors. They'll drift out over probably a couple of years if it was on all the time, and to be honest with you, I'm not even sure it's going to make a huge amount of difference. These resistors are the ones we use at work. A lot of these are mil-spec resistors as well, even though they are, a lot of stuff was commercial, so they should be fairly good quality. And also a lot of them are highly uprated. These ones here aren't carbon, they're some sort of metal composite, so that these will never drift out of spec. They're not a problem, but these are carbon. These resistors, I'm pretty sure these are carbon. And likewise, those resistors there, these tiny little RLR05s or TR4s, quarter watt resistors. Amazing difference in size between that and that resistor. Now I think that's a quarter watt resistor. It might be half a watt, but certainly the voltage across them, quarter watt resistor is more than enough. Anyway, that's I think the next thing to do is possibly put the bottom on it and do another sort of alignment check on it, see if we actually do want to make adjustments, because all the adjustments are here on the bottom of the radio, and it's going to be time consuming because it's got band spread on it as well. So I don't really want to adjust it if it's necessary, and initially it looks like it's pretty good anyway. So and at the end of the day, how critical is it? This radio is going to just end up sitting on the shelf anyway, like all my other stuff. Anyway, let's move on to the next step. I'm going through the alignment just to check to see if the RF alignment is somewhere within the ballpark. As you can see, the top left hand of the display, we've got the red and short showing the frequency it's putting out. And you'll see our pointer here. This is about the best I can get for the camera setup. So I'm going to tune this with 550 kilohertz, which is just here. We're looking for the maximum eye closure, or minimum eye closure I suppose. And you'll see about there, and you see it's pretty good on 550 kilohertz, so that's pretty good. So I think the next thing to do is to move up to the next frequency. Let's go to 700 kilohertz. I'll turn the generator to 700 kilohertz, and this is a lovely generator for using on medium wave radios. Something nice about an analog radio. So we're tuning for 700 kilohertz. You should see the peak around here. There it is. There it is. Pretty spot on. That's good as well. So okay, we'll go up to 1 meg. And again, pretty good. Let's go to 1.4 meg. And apparently I mistuned on one of the last videos, and someone pointed that out. Thanks for pointing that out. That's reassuring that I've the tuner is actually better than I thought. So it should come into tune about now. There, it's pretty good. So that's good. And let's try it at 1600. That's usually when they start to go out a little bit, and that's usually adjustment is usually done by sort of trimming, bending the fins of the tuning capacitor. Let's see if we can get that. There it is. That's pretty good, isn't it? Okay, so medium wave is, I'm not going to adjust the alignment on that. They are sealed with wax, and I say I don't think this tuner's been used, so I've got a funny feeling that it's pretty well in line. So we'll go to shortwave 1, and we'll start at 2.5 megs. So I'll take the generator to 2.5 megs. You see the eyes just come up. There's 2.5 meg. Just tune about. Hard to see, but 2.5 meg is there. I hope that's in focus. I did manually adjust the focus. That's good. So let's try at 3.5 meg. Just saw it flick past. 3.5 meg. Okay, we're slightly out there. You can see slightly off the 2.5 meg marker there, so that will be probably an adjustment to the capacitor of the oscillator trimmer. Let's try 5 meg. I just saw that come past. That's a bit out, and I expect it to be sort of like a progressively going further and further out, so I expect 5 meg to be a bit further out. No, it isn't actually. Stand corrected. So yeah, it's 5 meg marker. It could be slightly unlinear, but yeah, we're moving slightly back in if anything. Let's go to 7 meg. About to go to over range on the Version Schwartz because it's an analog signal generator. You actually manually change ranges. It's basically like an RF tuning circuit in this. There we go, 7 meg. Okay, that's not bad actually. Alright, so 7 meg is slightly back the other way, so it's going to be difficult to pull those in because one way it's running too slow and the other way it's running too fast. So that's pretty good. We might have a look at that, see if we can improve it, but I don't think we're going to get a lot of an improvement with that. Going to shortwave band 2, so we're going to start at 7 megs here. Oh, it looks like we've got an instability on the something or other, maybe the IF. I don't know what that is, but it's certainly unstable. Not sure what that is. You see that instability on the Magic Eye. Okay, we'll go up to, let's go to 8 meg and see if we can get anything. So I'm changing the range. Okay, we're quite a way out on this range. There's your 8 megs. Coming in about, oh, not hugely out actually. Slightly out. Go 9 meg. Now it could be unstable because the power supply I'm running off is a switch mode and it hasn't got any filter in it. It was actually designed as a medical power supply. They're pretty crude. It's a great power supply, don't get me wrong, but its output's pretty noisy. It's quite difficult to filter out the noise it generates. So here comes 9 meg. Let's see if we've got anything around 9 meg. Yep. It's pretty well aligned. I'm not sure I'm going to actually bother attempting to align this any better. I might try the other band. Let's go for 10 meg. Just seen that go past. Yeah, there's 10 meg. Pretty good, isn't it? So let's go. Let's spin on a bit. 14 meg. The range change again. Let's go to 14 meg. Much the same, slightly high. Right, it's 18 meg. It's becoming a bit compressed now, so this is 18 meg. Here it is. Pretty bloody good actually, and 20 meg. So top of the range again on the Roden Schwartz. Looks pretty good, isn't it? That's good. Slightly low now. So that's basically down to adjustments of bending fins and things on the tuning capacitor. Really not going to get involved in doing things like that. Not for a tuner like this. That's to me that's bloody good alignment for a tuner of its age. So let's just check a couple of the band spread channels. So let's try band spread 6. Is that band spread 6? Yep. Band spread 6 is this bottom one, so let's tune to 9.6 megs. So basic band spread gives you a sort of like a fine tuning. Let's see if we can get anywhere with that. Coming there, pretty good actually. So it's tuned to this 9.6 there. It's going to look worse on this scale. There we go. Yeah, so we're at 9.4. So band spread could be adjusted slightly, and I'm sure that's the same all the way through the range. It's probably very difficult that it's exactly right, but let's try band spread 5 and band spread 5. Let's try, say, 15 meg. Let's try 15 meg. Can't hear anything on this. That's 15 meg. Band spread 5. Okay. Looks to me like band spread 5 is possibly not working unless it's a dodgy switch. Oh look, band spread 4 is working. Band spread 4. Oh no, it is band spread 4. My fault. So band spread 4, yep, that's slightly out. So band spread 5. Let's go to band spread 5. That should be, sorry, 11.6 megs. Okay, that's my mistake, or my bad. God, I hate that term. 11.6. 6. Come on, where are you? Band spread 5, 11.6. Where are you? Come on. Band spread 6 doesn't seem to want to work. Checking. No, it's band spread 5, you idiot. That's what I'm on. Band spread 5. There. 11.6 meg. No, I've got nothing on band spread 6, so that needs looking at. Band spread 4 definitely works. Okay, so there's a problem with band spread 5. That could be just a, I don't know, it could be anything really. I suppose it could be a open circuit winding, it could be a switch problem, something like that. So I suppose it would be nice to have a look at that. It'd be nice to get it working properly all the way through. So that'll be the next port of call, possibly. Have a look underneath, see if we can see anything obvious. Have a look at the circuit, see how that band spread switching works, and go from there. Right, okay, it's just to confirm, I did this channel, this band spread 5 is actually working. Here's band spread 5, we're at 11.6 megahertz here. I'm just going to move it over to the Marconi quickly, and you'll see it's actually about reading 11.7. So it is working, it's just quite a way out, and if you see, look, There's the meter deflection. So that's good. The whole thing is working. It's just a little bit out of a line on the band spread, and obviously because it's such a widely spaced frequency, it's going to show up an error quicker if there's a slight drift on an oscillator or anything like that. So yeah, let's get into the alignment and see if we can pull these band spreads, at least these band spread channels in. I'm not too worried about the other ones. They're pretty spot on really for an analog tuner. So let's have a look at the service manual, see what it says. Right, we're going to try and align a shortwave 2 band. I've already performed alignment on the medium wave and shortwave 1 band. Seems to be fairly successful. So you can see in the background that the Broden Schwarz is at 7 megs. The tuning on the meter is at 7 megs, and we're on shortwave band 2. And it says adjust the shortwave 2 oscillator coil until the signal can be heard. And also, not just the signal can be heard, the maximum deflection on this multimeter. This multimeter is measuring the AGC voltage. The reason why I've chosen this multimeter is A, it's analog, but B, it's got a high impedance. It's got a FET front end, and it's 10 kilo ohms per volt. Not as high as I wanted, and the 2 meters I was going to use, actually I realised there are only AC voltmeters, so that they're not going to be any use. So we use this meter for the time being. So we're going to try and adjust the shortwave 2 oscillator, and that's the coil up here. Now we've also got to fight our other problems of wax in the cores, and also that they're recessed quite a long way. I'm going to go in and try and adjust this. So I'm looking for maximum deflection on the voltmeter. Now, yeah, we're full of wax. So what I'm going to do is I've got the soldering iron turned down to a low heat, and then just quickly, this is the oscillator coil, just stick the iron in there and soften the wax up. Be careful not to touch anything that's sort of like could melt and damage itself. You know, we're only touching the core at the bottom just to melt the wax. We should be able to get in now. Okay, I can feel the core. So I'm going to adjust this core for maximum deflection on the meter. Look at that, spot on. Okay, so that's it's sort of reassuring me that this radio is pretty well aligned. Now I'm going to tune to 20 megahertz on the Broden Schwarz. There we go. And align the tuning dial to 20 megs on the shortwave 2 band. Just doing that now. You can actually see that aligned now. We've got good deflection. So we're looking for now. Let's see here. Bring them up slightly so you can see. So this is, we've done the oscillator coils, the low frequency. This is the shortwave RF frequency. Now I'm going to use a pair of pliers. I know that's not the way to do it, but I can remove the tool and make sure that the deflection stays as high as possible. So we're looking for maximum deflection again. Shortwave 2 oscillator. See, it's adjusted it slightly already. Oh, come on. Yeah, it's very jumpy, that. So I need to really find a plastic tool to adjust that. I don't know if I've got anything that's plastic, that's the trouble. But we're looking for maximum deflection. Obviously we've dropped back a bit, so let's just tweak that again. There you go. Brought that right up. I'm going to bring the RF down on the signal generator. See if we can get any higher. Okay, we'll drop back. These are very touchy, these controls. Brought it up a bit higher. Cool, blimey. So we've got a bit of gain on that. Turn this down a bit further. More. We've got some improvement in sensitivity out the shortwave 2 band anyway. Okay, I think we've pretty peaked at that. Yeah, we've peaked. Okay, so So what I'm going to do now, this is a Beehive, Mullard Beehive tuning capacitor. These are, I like these things, but they're fairly stable. What I'm going to do, once I've got the figure as high as I can, it's very, very jumpy, as you see. There we go. Pretty highly peaked. So what I'm going to just do, I know the unit's on, I know this is ground potential, just run the soldering iron around the top. That remelts the wax and seals the capacitor in place. So that's that section done. Now that's the oscillators. That basically means that the tuning dial should be fairly accurate. The next stage is to do the aerial matching and the RF gain. So reading through, it says so we've done the oscillator, and you go back and check the oscillator at the low end frequency at 7 megs. So we're going back to 7 megs on the generator. This is a lovely meter, but sometimes it's just easier to just punch in the frequency when you're doing things like this. It's great for sweeping frequencies and things. Go back to 7 meg. I'm not so interested in its sensitivity now. I'm more interested in it. The 7 meg is actually 7 meg on the dial. I'm coming to 7 meg now. You should see the meter jump up about now. Yeah. We have moved slightly actually. So we're at 7 meg. Okay, we've lost a little bit of gain, so I'm going to readjust the 7 meg oscillator, and after that I'm going to leave it as it is because we'll be chasing our tail otherwise. So the wax has gone hard again. This is the only problem with these old sort of radios. If they seal them with wax, you've got to melt the wax every time. It's a good idea because it does hold everything in place, but it does make it a pain to calibrate. No, we're pretty much peaked. I'll turn the gain down obviously as well. The RF gain's come up a bit. Yeah, so we're basically we're in position. I think 7 meg on band 2, 7 meg on 2. Yeah, you're not going to get any better than that. Oh, there's 7 meg. Okay, so we have moved off slightly off tune. Actually, we've got quite a bit of signal strength back. You see, we've pegged that meter now. Alright, so that's good. We've got more sensitivity on the shortwave. So I'm going to go through this a couple of times and then we'll move on to the aerial tuning. Right, the next stage is to do the RF coil. So we're going to tune to 7 megs. We're going to make sure that we're tuned in for the maximum signal deflection. With the tuning meter, we're basically probably pushing too much signal into this tuner, so I'm going to turn the signal down, go to another range. You don't want to activate the AGC, because if we activate the AGC then we can't see the woods for the trees, basically because the amplifier is limiting. If I just make an adjustment and then we get an improvement, you won't see any response on the meter. Right, so we're at 7 megs, so we're on the low frequency side. We want to adjust the coils of the RF section and the aerial section. So these are the two here. This is the RF section. So this matches the tuner to the front end of the radio. Now you're supposed to use a 300 ohm aerial input. I'm basically using a long wire, which is basically what this tuner will actually probably see in real life anyway. Just move that ground point out of the way so it's not in view. So all this adjustment will do, it won't actually adjust the tuning of the radio, but what it will do is it will adjust the sensitivity. So we're doing the coils because we're doing the low frequency side, similar to the oscillator, but we're just adjusting the coils to get maximum matching on the front end. So we're coming in here, watching for maximum deflection. Okay, slight improvement. So that's the aerial matching. The room smells of burning wax and rubber, because there's also a rubber band that locks these in. This is the RF amplifier matching. Might get a slight improvement on this one. There we go, got maybe a couple of dB improvement on there. So that's the low frequency side, they're the coils of those. Now we're going to move to the high frequency and adjust the bumblebees or beehives, whatever they call them, on the high frequency side. So let's readjust to our high frequency range. So we're going to 20 megs. And quite honestly, you don't really need a signal generator for this. If you've got background noise at 20 megs, you just adjust them for peak signal on the meter. But let's do it by the manual. So go 20 megs. And this time we're tuning in to get the maximum signal strength. So adjusting the tuning. It's very, very touchy. And I'm getting lots of harmonics, but you've got to bear in mind this is an old tuner, and it's pretty poor for rejecting inter-channel frequencies. So you know, if I've got something at 20 megahertz, you probably find its rejection to 20.1 megahertz is not as good as a digital radio or digital synthesized tuner. So we're at 20 megs. We're going to go through and adjust these beehives. So we'll start off with the aerial amplifier. So we're adjusting shortwave to aerial amplifier. We're at 7.5 now. We can see if we can improve on that. Doesn't look like we can improve a lot on that. It's always quite reassuring if you can't improve on something. It probably means that you're doing it right. Very difficult to adjust these because they're in a deep recess. I think 7.5 was about as high as we're going to get it. Can't get it to 7.5 now. It's typical. Check we haven't lost tune slightly. Might have slipped. The trouble with these tunes are they will drift slightly, and it has drifted actually. It looks like it's drifted. Let's readjust it. Back on tune. Okay. So we're looking for maximum signal strength. Okay. It's about there. So yeah, I'm happy with that. So let's go to the RF tuner. I'm going to turn the gain down slightly, so we're not. Okay, just as we're finishing that section, the bloody camera ran out of memory card, so I've restarted again, and we're going on to the RF section. So we're just mounting the shortwave coil. So this is going to complete the RF alignment on the shortwave band 2. Got a tuning core in there. We're looking for peak on the meter. This is a bit tight, this coil. Let's reheat it again, because you can't force these coils. You force them you're going to guarantee you're going to end up breaking the core, and you won't be able to adjust it after that. So never force these coils. There we go, and you see that's pretty well peaked. That I didn't get any improvement on that at all on the meter. So that's section 1 and 2. That's medium wave, shortwave 1 and shortwave 2 correctly aligned. That remains to do shortwave 3, which I'll do that off camera. We'll get that aligned, and then you'll get a good idea of how the radio performs and how well it's aligned once I've finished. Right, it's another one of these videos where I'm trying to cram everything in so you can see what's happening. I'm trying to get the band spread ranges somewhere near where they should be. They're a little bit out. Obviously the oscillator has drifted slightly, and that's why we've had to bring the whole thing back into alignment. So 9.3 megs, scales on 9.3 megacycles here. We're looking for a peak on this Magic Eye. So I'm adjusting the band spread adjustment on band spread 6, which is this one. I have melted the wax, but it's starting to become hard again. We're looking for maximum deflection on the meter, so I'm just going to tweak this slightly so we can find. Looks like our signals around there. If I rock the frequency backwards and forwards, it's just at 9.4. So I'm very sensitive this actually. See, it's about 9.4. 9.34, 9.32. There it is. That's pretty good. Go a little bit further. Yeah, that's pretty good, isn't it? So that's 9.3 megs. So that's the oscillator adjustment. Now the next one we'll do is the low frequency. Band 6 will do the RF amplifier. So I'm going to melt the wax again. Now what we're looking now for is maximum gain. So I'm just going to put my iron onto the core. Just have to bear with me a minute whilst I do this. I'm just heating the core up, melting the wax. All I'm going to do now is just tweak this control. I'm not touching anything on the signal generator for we want maximum deflection on the meter. We're pretty there anyway. That's good. You see that it peaked up slightly. Just bring the meter down, scope the camera down slightly so you can probably see the Magic Eye a little bit better. The trouble is it does tend to wash the Magic Eye out a bit. Let me just try and turn the exposure down a little bit for you. It might make it a bit easier to see the Magic Eye so it doesn't just wash out. Okay, and now I'm going to go for the RF amplifier. Am I going to the, no, I'm going to the aerial tuning. Sorry, I've just done the RF amplifier, adjusting the coil for that one. So I'm just melting the wax in the core there. I'm going to turn the signal down on the generator slightly so we can see clearer if we're having any effect. Adjusting again. Peaked it up slightly. So that's the band spread 6 done. I'm going to go to band spread 5 now. On band spread 5. We're going to 9 point, I think we'll do band spread 5, we'll do, okay, this is 14.75 megahertz. I'm not going right to the end of the scale, I'm sort of starting it sort of halfway through the scale, so it gives you a better linearity. So we're looking for 14.75, so we're tuning the signal generator to 14.75, looking for the peak. Just checking again, the band spread 5, we'll make sure we're on the right scale. No, sorry, it's 11 point. Well, it's always worth checking, double checking. 11.4, I beg your pardon, so it's 11.4 megahertz we want. So let's go back to 11.4, you should see the peak go past at 11.4. Any second now. No, nothing. So, band spread. It should be definitely 11.4. Turn the signal up a bit. Oh, there it is. 11.49, you see it. Okay, so we're going to do the same thing again. We're going to set our 11.75 and we're going to adjust our oscillator so it puts the scale in the right position. Let's get that central. So we're in band spread 5 oscillator, just loosening the core for that one. Softening the wax. Okay. In with the trimming tool, I'm looking for the peak. There it is. Really, really jumpy. There we go. 11.45. 11.45? I thought we were supposed to be doing 11.75. Okay, it's 11.75. Okay, let's do it again. Oscillator 5, band spread 5. Where are you? So the wax is starting to become solid again now, so it's all getting a bit sluggish. Okay, can't find us. Where are we? It's there. No. Pretty good, isn't it? So that's the oscillator done for band spread 5. Same thing, turning the signal down. Going to adjust the RF amplifier and the aero matching. So I'm getting RF amplifier for band spread 5. Softening the wax up. I mean, you don't have to watch all the way through. This is documenting it more for me than you. Just so I've got reference of what I've done to this thing. Adjusting the core from maximum signal. Peaked up slightly. Going to the aero trimming. The workshop absolutely stinks now of melted rubber bands and wax. Band spread 5. Peak that up a little bit as well. Okay, so basically I'm going to go through the rest of it and then we'll have a go, see what it sounds like. Well, I've gone through it and realigned it. It's a really nice set to realign actually, apart from the wax and the inductors and things. It's pretty straightforward. It's a bit complicated with the band spread because you've got the band spread adjustments as well, but the shortwave 1, 2 and medium wave are the sort of standard adjustments you have with any sort of super het with an RF amplifier in, so it's pretty straightforward. So I'm just going to run through now and just see what we get for alignment. We tuned in at the moment to 550 kilohertz on the medium wave band. It might look like it's off tuned to you, but it's just parallax from the camera. So we're just going to run through so we can make sure our alignment's correct. So let's go to 550. Okay, it's about 550 there. Just check our tuning. That's pretty good. Let's move it up to 700. I'll turn the volume up a bit so you can actually hear the signal generator and turn the RF level up a bit. 700 kilohertz. It's pretty good as well. Let's try out 1 meg. It's good as well, as you see. We'll try it at 1400 first, but I doubt 1600 will come in. Let's try it. Okay, it's like, yeah, just in on 1400. We'll try 1600 as well. Oh, that's pretty good. Okay, so medium wave calibrations on the scale is excellent. Shortwave 1, back to the other end of the scale, start at 2.25 meg. We'll just do a couple of checks just to see what we've got. 2.25, 2.24. Pretty good actually. Let's try 3 megs. Yep, pretty good as well. Pretty. 5 megs. Okay, slightly out on 5 megs. I've gone a bit high. 7 megs. Yeah, so it's gone a little bit high at 7 megs. So that's a bit of adjustment on the local oscillator capacitor just to bring that down. But it's certainly not bad. I'm not too worried about that. There you go. So it's pretty good. I don't want to go through the whole thing, but let me just do one of the band selects, the band spreads, should I say. So we're on band spread 5 here. It's not very clear, I know, on the camera. That's 11.6 megahertz. Now there's no adjustment for scale linearity or anything like that. You've just got an oscillator that will actually bring you into the right range. There's no trimming capacitors or anything like that. So let's try 11.6 then. There you go. Pretty good. And just check for scale linearity. I don't think it's that great. So it's at 12. Pretty good, actually. Quite pleased with that. So, basically, to sum up, I think the Chapman's basically going to work as well as it's going to work. It's a nice valve set. Pity it hasn't got FM, but it's got quite a usable short, medium wave and short wave band, and it seems to be pretty sensitive. I've actually got the sensitivity control turned right down at the moment. Obviously won't resolve single sideband or anything like that without an external device, but yeah, it's been a pleasure to restore this old thing. It's certainly in good condition, and I think, as I said before numerous times, I don't think the thing's had a lot of use. These two beehive capacitors I haven't mentioned. These are basically band spread. It looks like adjustments for the RF amplifier and the local oscillator for high frequency. So basically the same as the controls underneath, but they only do the band spread, and they do for all the band spread. That they are sort of like they're basically just there to do band spread, and they don't make any difference at all to the shortwave or medium wave bands. Anyway, thanks for watching, and more to come.